Well, then let's get going. So what we are going to do is the topic that we're going to be covering is exponents and surds. That's the topic in general. And today's lesson focuses on exponent laws and simplifying. And so I want to start with a multiple choice question. Now, I don't want you to answer it yet. I just want to ask you to take a moment and consider this. And then once I've given you some time to think about it, once you're ready to answer, won't you just give me a thumbs up? And then I'm going to release the polling thing. So the question is, which of the following is a power of 5? And once you're ready to answer, won't you please just give me a thumbs up? Don't give me the answer, but I just want to know when you're ready that you feel like you can answer the question. Which of the following is a power of 5? All right. So I'm going to now release a poll to you, and I want you to put the answer that you think it is into this poll. So A, B, C, or D. Which of the following is a power of 5? Keep it coming, ladies and gentlemen.
Achilles says easy.
Don't worry, this is the warm-up. This is the stretch. A good instructor always knows to warm everyone up first. Otherwise,
yeah, we don't want to scare you guys away yet.
Okay, who would like to share their answer with us? Pop your hand up and you can tell us, and then I'll release the results in a moment. But who feels like they'd like to answer?
Anybody?
Pop those hands up and you can tell me what you think the answer is.
I promise we're nice.
So nice. So nice. Lebo is very nice. No, I'm joking. Yeah. Okay.
Oh, Craig.
All right. Craig, what do you think it is? What do you think the answer is?
So I think the answer is 125.
Okay, I agree with you. How did you get it?
Because if you the root back 5 and 5, or 5 times 5 is 25. So if 25 times 5 is 125, if you divide it by 5 as well, it should give you 25 as well, which means that makes it the main multiple.
Yeah, exactly. So 25 is 5 to the power of 3. And I'm just going to release the results to you. Well, actually, I can see them. I don't even need to release them, but it was helpful for me to see. Okay, so I think that is a good start. Why is 100 not a power of 5? Well, because 5 won't go exactly into 100. And the same with 500 and the same with 55. Cool. Are there any questions about that, or can we move on? Are there any questions about that? Then we're going to move on. Okay, so the correct answer was D. Let's go to a next question. This time, I'm going to give you, let's say, 25 seconds, 30 seconds to try and answer this question.
Go for it, guys.
And then you can put your answer in the chat. So in the chat, you can just put A, B, C, or D based on what you think is the correct answer. Okay. Keep those answers coming, ladies and gentlemen. So to solve this question, you need to know about a certain exponent law. I'd love for someone who feels confident to tell me what they think the answer is and explain to me what they thought about when they solved this problem. So who would like to put their hand up and help me with that? And then I'll reveal the answer in a moment. But there's a particular mathematical idea that we need when dealing with exponents. So let's go to Sino. And Sino, how's it going with you?
So I think that basically when you multiply exponents and you see that they have the same base, then you add the exponents together and keep the base the same.
This is so important. So Sino has spotted that the bases are the same. And say what you said again. So you said, what do you do?
When the bases are the same, you add the two exponents. So 4 plus 3 will give you 7.
So you get 3 to the 7, and 3 to the 7 is A. So I assume you got A.
Yes.
Awesome, Sino. You are winning at life. Thank you so much. So we call this law 1. And when we multiply two like numbers that have the same base, we simply have to add the powers to get the answer. Now, there were a couple of you that got C and D. So notice how when we multiply numbers that have powers and they have the same base, it's a shortcut to use this law 1. And sometimes in your textbooks, what they often show you this law as, they show it to you as something like that, and in fancy variable land. And that's an important law that we use in this topic. Okay. Let us move on to another warm-up question. And let's see how this one goes. So I want you to simplify this expression, and I want you to choose one of these 4 options. You can put it in the chat, and yeah, let's see how you go.
Keep going, guys. You're doing so great so far.
You do very well. We're dusting away those cobwebs. Chop, chop. So I see quite a few people in the chat who are locking in the answer. Would anybody like to tell us about their thinking and how they got the answer? Anybody willing to share for this next one? Because in maths, it's often about the thinking that goes in as much as the answer. And so if you're willing to share your thinking, we all benefit from that. Anybody know the thinking behind how we get the answer for this question?
Oyisa.
Oyisa. Hi, Oyisa. Can you hear me?
Yes, sir.
Hey, how did you do this one?
So we were taught at school if the bases are the same and it's a division, you subtract the exponents.
Yep. It sounds very similar to the last one. So you write down the base, and then because you're dividing, you subtract. So what was your answer then?
It was 2 to the exponent 5.
Okay, which is B. Perfect. And so this is law number 2, that if the bases are the same, we will simply subtract the powers. Guys, you are looking good to me. So if I'm going too fast, let me know in the chat, but I'm seeing good things so far. But it can be that some of you you're unsure, so please do feel free to ask a question. So the first law is just the addition. So when the bases are the same, you add the powers if you're multiplying. Whereas the second law is if the bases are the same and you're dividing, you subtract the powers. Okay, so Kile, I hope that helps, but I will give you a summary later on. But for now, we're just practicing on understanding it. Okay, let's go to a third question. And there are basically 3 main laws. So here is your question 3. I want you to simplify this and choose option A, B, C, or D. Pop it in the chat. Pop it in the chat.
Keep those answers coming, guys.
Now, this is a little bit sneaky because there's a power and then there's another power. This is a powerful question, right? So you need to watch out here. Okay. Which option do you think it is? And then I want someone to tell me, how did you figure out this whole power to power thing? I see answers appearing in the chat, which I'm liking what I'm seeing, but I want to know, how did you think about this question? And how is it different to the other ones? Just pop your hand up if you are willing to share your perspective. It also gives me a chance to get to know you and hear your lovely voices.
We love to hear your voices, guys.
We do. Who's feeling like they want to have a go at explaining this, or just thinking through it? So if I'm looking at the chat, most people have said A. I don't see too many other variations. So when I think of this question, this is, for me, it's law 3. I call it the power law. And basically, if you've got a power of something, and then you've got a base below it and another power, what you generally do is you multiply the two numbers together. And so you would get 5 to the power of 12, which would be answer A, which I agree with you. But what I find with a lot of students is they don't always understand why this is true. And so just to show you what 5 to the power of 4 to the power of 3 means, it basically means this. It means you have something like to the power of 3 means multiply something 3 times. And what is that thing that you repeat multiplying? It's just the 5 to the 4. So that's why I've got it once, twice, 3 times. And if you think about law number 1 says if the bases are the same, you write down the base and then you add the powers. And so you can see that it makes sense. We get 5 to the 12. It's just that if powers are next to each other like this, a shortcut is to multiply them. Give me a thumbs up if you feel good with that. Thumbs down if you feel a bit unsure. I just want to get a feel for the group, and because that's the foundation. It's the first 3 laws, and I'll even write them out for you now if we need to. Okay, awesome. I think, yeah, let's do this one just very quickly. What is 7 to the power of 0 the same as? Always good to know. The power of 0 is a bit of a weird one. Like I know 7 times 0 is something, but this is not the same thing. It's something different. It's 7 to the power of 0. So this is a bit more tricky. I like it. I see a bit of variation in the chat, which is good. So when we deal with exponents, anything to the power of 0 is going to end up being 1. Okay, so if we had 8 to the power of 0, it would have been 1. If we'd had AB to the power of 0, it would have been 1. And that's an important idea that comes up again and again through this topic. And I'm sure you've seen it before, but it's just important to remind you where it came from. And I mean, if you really want to understand kind of where it came from, think of this. If you think of what is 7 to the power of 2 divided by 7 to the power of 2, well, that's going to be 1, because anything over itself is 1. But using the law that we learned about earlier, if you've got 2 bases and you're dividing, you write the base down and you simply subtract the powers. And then you can see that 7 to the power of 0 is 1. Now, you don't need to do this working out, but I just want to show you that the world is coherent. Okay. Awesome. So what have we learned so far? Let us do a quick little summary, and you can write these down if you need to. Law number 1 basically says if the two bases are the same, in this case, I'm using A as the base, and you're multiplying, you simply add the powers. Law number 2 says if the bases are the same, those are both A's, and you're dividing, oh, what's going on here? Sorry, guys, my pen has gone a bit wonky. Let me, oh, I've made it angry, guys. This is...
Oh, Mr. Ace.
I know. Maybe I can control Z my way out of this rather. Let's see. No. Okay. Well, let's have a look. Maybe I can use my mouse. Okay, I'll use my mouse to draw, but it's less accurate. So the second one is just that you subtract the powers. And then the third law is just that if you have a base and it is raised to a power, then we get, and these two are multiplied. Cool. So I'll give you a moment. Are there any questions about the laws, or just give me a thumbs up if you feel comfortable with the laws? And then I'm going to move on. Okay. Well, let's do a slightly more spicy one before we have our break. So I'm not going to do this first one here because well, maybe I should. Let's do these two for the break. So I want to know what is the answer to this one to start with. So simplify 4 to the power of 6 divided by 4 to the power of 3. And I want you to tell me what the correct answer for that is in the chat. Okay. Lebo, what do you think? I get the impression that students
I think they're nailing this. Yes.
Okay, so the bases are the same. Okay, so the bases are the same. Draw. And since they're the same, we're dividing, we just subtract the powers. And so we get 4 to the power of 3, which is option B.
Well done, guys.
Yes, Ayanda. Okay, now, you guys have been doing very well so far, and I feel a little bit like you're like, oh, so where's the action here? So I'm going to ask you to try and do this question. Now, we might need some help from the audience in this one, but I want to see, first of all, how it goes. So I'm asking you, simplify if possible, 20 to the power of 6 divided by 4 to the power of 3. And I want to see if you can work this one out. What will that be using your knowledge of exponents? And then while you think about that, I'm going to get some water and see if you can just lock in an answer, even if you're not sure.
Go ahead and try it out, guys.
There's something a little bit different about this one. So lots of people are going for A. Now, I don't know what the answer is. I still have to work it out. Would anybody be willing to share their thinking with me about how they got the answer? I mean, I don't know. I'm gonna have to work it out now myself. Yeah, let's go to Sia. Sia, what was your thinking? How did you approach this?
Hi to everyone.
Hi.
My thinking was that since the bases aren't the same and we have to divide, we're gonna have to divide the bases, and then we're gonna get 5, and then we minus the powers, and then we got 3, so it's 5 to the power 3.
So did you tell me about the 20? What did you do with the 20?
I divided it by 4.
You divided it by 4. But how did you, let's have a look. So I was thinking, couldn't we break the 20 into its prime factors? Did you do that or not?
No, so I just divided.
Divided. Because I was thinking, like, if you divide it by 4, okay, so I sort of get what you're saying, but I think the problem is we need to actually break. So let me try and work this out now, and then we'll see where it goes. But I see what you're saying. You're saying, look, 20 divided by 4, but the problem is the bases aren't the same. And what I noticed is earlier in the lesson, all the laws seem to really like having the same bases. So can't we possibly take 20 and write 20 as a product of its prime factors? Now, I don't know if you've seen this before, but 20 can be written as basically, we can divide it by 4, and 20 divided by 4 is 5. So you could say 20 is 4 times 5. And that's quite helpful, because now what you could have is you could have 4 times 5. Sorry, guys, my pen isn't working. I'm just going to use my mouse. To the power of 6 divided by 4 to the power of 3. So just take a moment and see if you agree with, I'm not saying the answer's there yet, but do you understand what I've done? Give me a thumbs up if you understand what I've done there by breaking the 20 into 4 times 5. And now, does that change your answer? Because I was thinking there's another law that says you get, if the 6 is outside, there's a 1 here and a 1 here, which means you can write this as 4 to the power of 6 times 5 to the power of 6 over 4 to the power of 3. So I'd love a question if you're unsure at this stage, but what I did in this question is I looked at the 20 and I said, look, it's not the same base. I'd love it to be the same base. What can I do? I can break the 20 into 4 times 5, and that gets me a 4. Now, what I have is, yeah, let's go to Oratile.
Hi everyone. Hi sir. So
Hi.
I wanted to ask, if you separated the 4 and you separated the 20, right? And you said it was 4 times 5. Can't we just make the 5 into an exponent so that it can be like 4 times, so it'd be 4 then an exponent 5 times 6, but then the 5 isn't like inside the bracket and the 6 is outside.
So what I was thinking was it would be really helpful. I get what you're saying, but I was just thinking we could focus on these two over here, because we know that 4 to the power of 6 divided by 4 to the power of 3 is just going to give us 4 to the power of 3, because we can subtract the powers, and then what's left behind is 5 to the power of 6. Does that make sense to you?
Yeah.
Okay. Now, if I look at this as it stands, there isn't a number here that it adds up to. And so what I would get here, unless I've gone 5 to the power of 3, yeah, I would get this one over here. So Letabo, let's go to you. What's your question?
Hello, sir. Can you hear me?
Hey, loud and clear.
Sir, I don't understand the equation you did, because whenever I do it on my calculator, it gives me 1 million.
Yeah. Okay. So it's a very big, it's quite a big number. So tell you what we're going to do. We'll come back and talk about this type of question again. But all I wanted to point out to you in this question is the bases weren't the same. When the bases are not the same, it's a good idea to break the base down into a smaller thing that has the number that you were looking for. So give me a thumbs up if you understand that how I got 20 is 4 times 5. That's what I'm really concerned about. Okay, now give me a thumbs up if you understand how I got from the 4 times 5 to the power of 6 to 4 to the 6 times 5 to the 6. So basically, do you understand how I got this bit? Give me a thumbs up for that. Okay, now, if you imagine the 4 to the 6 divided by 4 to the 3, we should get 4 to the 3. So give me a thumbs up if you understand how I got that bit. All right, and so what we see is that none of these options over here are going to fit that, and so we go with this one over here. But that was a tricky question, I agree. And I was just trying to push you a little further before the break, but now we are due a break. So what we're going to do is we are going to turn our cameras on and we are going to have a stretching break. And if you can accompany me in standing up, turn those cameras on. I want to see your lovely faces, and I'll even, oh, there we go. Look at the humans out there. Yes, please.
Please join us on the stretch, guys.
All right, and let's do this.
Your brain needs a break. Let's see your lovely faces. Turn on your cameras.
Okay, so what I want you to do is I want you to just roll your shoulders. Roll your shoulders nice and back. There we go. Oh, how good does that feel? Thank you, maths teacher. Roll them forward.
All teachers should do this.
There we go. Then do the nice tricep stretch. Oh, there we go. Another one on the other side. Your body's like, oh, thank goodness. This one.
Oh, yeah. You're going to feel so refreshed after this, guys.
Exactly.
Your brain will be on steroids.
And then just swing around a little bit just to get you nice and loose. And then shake it out. There we go. Shake it out. Yeah.
Nice one, guys.
Oh.
Shout out to Sia, Craig, Ayanda, Annie, Kumo, Pumelele, Siatemba, Shirley, Sichava, Orikonisa. I hope I pronounced that right. Hope you enjoyed that, guys. Woo!
So, yeah, that's where drama class know what they're doing with their warm-ups and their cool downs and all that, right? You just unwind your body. So, next part of the lesson is we are going to do a little brain break challenge problem. I don't know if you've seen this one before, but I've given you a series of, well, basically Christmas sweets. And I want to know what a red one plus a purple one times a blue one is. And you have to use your mathematical cunning and knowledge to figure that out. And then tell me if you...
Ooh, the suspense.
Who's it going to be? Oh, let me just put my camera back here.
We have our first final answer.
I like it. There's a bit of variation, which means, so Asa and Pumelele.
Keep them coming, guys.
Yeah. I want you to think, which of these 4 equations would you take on first, Label? Which one do you think you would out of the 4?
I would do the blue seeds first.
Aha, the blue ones. I'm with you.
Yes.
I'm with you. Okay, a couple of other answers coming through. Let's see. Why would my pen work? So weird. My pen has just literally stopped working. Just use my mouse for now. Okay, let's see what's going on. So I think that this one over here has to be 3 times 3 times 3. And that has to be 3. Well, that has to be 3. And then for the next one, once we've got that one, what else can we do to get going? Well, this is going to have to be 1 and 1. So that's going to be a 1 and that's going to be a 1. Because 6 times 2 will give you 12. And then the last bit, this is going to have to be a 4 and a 4. And that's going to have to be a 4. So what do you get as your final answer using BODMAS?
If you would like to change your answer, maybe you're reconsidering now. This is your chance.
Or if you disagree with me, see if you disagree with me. But like, I was just thinking, if that's 1 and that's 1, that's 2. That's right. 3 plus 3 is 6. So BODMAS says you have to do the multiplication before you do the addition. That's the tip I'll give you. And so you should get 13. All right.
Awesome, guys.
13 is the correct answer. All right. How did I get 24? Don't worry. See, you understand how I got 3 for the first bit? And then I used that 3 to help me get the red. And then I used the red to help me get the purple. And then I just did the last bit with BODMAS. Okay. All right, let's keep rolling. Let us ask ourselves, let's try and do this one.
Whoa, Annie got a decimal. Yikes.
Okay, next question. So again, what is today all about? Today is about understanding when we can use the exponent laws and when we can't use them. And they are a little bit strange looking. But normally there's one important idea you have to look out for. And so think about what that idea is, and then ask yourself for this question, if you think what you think the answer is. Put that answer in the chat there, ladies and gentlemen. Okay, we have lots of C's in the house. Do we have anybody else who's not a C? I see. Haha. Now, I'm thinking back to the laws earlier in the lesson. What was the important thing I had to look out for? Can anybody come online and tell me what is the main thing I'm looking for when I'm using exponent laws? What am I looking for? So let's go to, can we unmute Annie? Can you hear me, Annie?
Hi, Annie.
What do you think, Annie, that the main thing that we're looking for is? So Sia has said the base, but I would agree. The base. Now, are the bases the same in this question? Well, the one base is 4 and the other base is 3. So the bases are not the same, which means we can't add the powers. So is the answer still going to be C? I'm afraid, ladies and gentlemen, it is not, because the bases are not the same. And so because the bases are not the same, if it had been 4 to the 5 times 4 to the 2, then we could have said 4 to the 7. We would have just added the powers. But then in that situation, the bases were the same. However, in this situation, that's not the case. So what's the answer going to be? So the answer is, let's see a few more of you think about it. What's the answer? The answer is going to be D. So in this case, because the bases were not the same, we actually couldn't add the powers, and none of these actually make sense according to the laws. So it's going to be D. Are there any questions or comments about that? I know these questions are designed to really make you get to the edge of your thinking. And what this is trying to do is show you that seeing the bases are the same is really important for this section. If you start making up laws where the bases are not the same, you have to be very careful about how you use it. So Oratile, in this situation, you would just leave it as is. In the particular question, normally this type of thing would be part of a larger question, in which case, if we had something like this, if we had 4 to the 2 on the bottom times by 3, then it would be a different situation, and we would allow these bits could interact and this bit could interact, because you have things that have the same bases. But as the question was phrased originally, no, it just said it's not possible in this situation. So I hope that helps you, Oratile. Okay, well, let's go to Kumo's got a question. Kumo, let's go to you.
Sir, I just wanted to ask if the bases are always different, should we always know that it is not possible to simplify for like every equation?
Okay, so this particular multiple choice question is not a very common exam or test question. I'm just trying to look for holes in your understanding. But normally what will happen, Kumo, is that you would have other numbers or other things in the question that they can interact with. Very rarely will you get it, but yeah, if it's just this, then you would basically just use your calculator to get what the number is, or you wouldn't even do that. You couldn't really go further than to work out what 4 to the 5 is, and then times it by 3 squared, which is 9. And it's just a multiplication problem, really. Okay. Let's have a look at another one, because today is really just about practice and getting into, can you do this one? Simplify, if possible, the following one.
Try it.
Think
out,
about
guys.
what we've learned so far, and then see if you can recognize the ideas. And I know I'm making your brain hurt now. I did promise I'd turn up the heat, but just think about what are the fundamental ideas. So are the bases the same here? If they are, what operation is between them and what do you do? Okay, so for me, the base in both situations is an M. And if that's the case, I would just write down an M, and then I add the powers, which is going to be M to the 5. And so the correct answer is going to be A. Lanelo, you are absolutely correct. You add the exponents. So yeah, I love what Lebo said there. Keep those laws. You really want to get to know these laws really well. And the way you do it, obviously practice, but yeah, I mean, that's what you're here to do, right? You're here to practice, and you practice in the quiz at the end of the week and so on. Okay, let's leave that one out for now. Let's finish with doing these last three, not all of them, just three. So let me zoom in for a second and we can. So I want you to try and get me the answers to these last three, and then we're going to call it a day for today. Okay, so by yourself, I want you to try and get the answer for 1, for 2, and for 3, and then put your answer in the chat.
Last push for the day, guys. Hang in there.
You can do it.
Stay with us.
Keep those answers coming through. I like what I'm seeing, Sechabo. I like what I'm seeing, Sino. The one that looks a little bit sneaky is number 3. Oh, let me just close the door so that we don't hear the siren. So for number 1, the answer is going to be y to the power of 4. And for number 2, the base is the same, and we're going to subtract the powers. And we're going to get that. And so it's only number 3, which is a wee bit more sneaky. Maybe someone can come online and give me the answer for number 3. I'd love to hear your lovely voices again. And you can just tell me what law are you using and what do you get. Sino, let's go to you.
So for number 3, I took the 7 and added it to the y, so it's y to the power of 7.
Okay, so you applied the 7 to here. Okay.
Yes. And then for the x, I did the same thing. I applied the 7 to the 2. So you multiply them, which is law 3. So you say 2 times 7, and that gives you x to the power of 14.
Okay, so you got y to the 7 times x to the power of 14. And yes, so basically the first one was law 1, this was law 2, and this was law 3. Okay, so what I would encourage everyone to do today is to, before the next lesson, go back and have a quick look at the laws again. And in the next lesson, we'll take it a bit further and look at how we work with these in slightly more detailed questions. But for today, you've done very well. And all I'm going to do to finish the lesson for today is just send out a poll just to ask you about how you found this first lesson. And so because this is something quite new that we're doing, we really value your feedback. And so I would love if you could give us some honest feedback about how you found the lesson today. That would be fantastic. And then we can wish each other well, and we'll bring the lesson to a close.
Thank you so much for your participation, guys.
It was fun. And also like respect for getting in there early, getting into the gym early. You'll see I use exercise analogies a lot. And you know, it's like you're in the gym, like you're getting ready for the journey.
Exercising that what muscle in the brain.
Yeah, I feel like I should have Rocky music.
Oh, I like the guitar. I think we should have
Yeah.
that again.
We'll bring that back at some point, definitely. All right, Asanda, what's your question?
Hi, sir.
Hey.
Please, can you explain again number 3? I didn't get it actually.
Okay, so number 3, what this is saying is there's something inside the bracket, which is y times x squared. So are you okay with that?
Yes, sir.
But now the question is, how does the 7, which is outside, apply to what's inside the bracket? And so, Level, did I take the screen thing away? I think I did. Or it showed the poll. Is it?
No, I can still see it, Mr.
Oh, can you see it? Maybe just take a screenshot so I don't forget.
Okay.
And so then, Asanda, what you do is law 3 says if you've got powers and then with powers outside, you simply multiply what's outside by the powers that are inside. And so 1 times 7 is 7. And then with the x, there was a 2, but 2 times 7 is 14. And so that's how you get the answer.
Okay, thank you, sir.
Cool. All right. Thanks, everyone.